Okay, so we're going to take a look at section 4.5, part 1. We're going to be looking at finding solutions of polynomial equations and finding zeros, which is really the same thing as finding solutions. A new term we're going to look at is called the repeated solution. This is also called multiplicity. This is going to be when a factor appears more than once. When the multiplicity is an odd power, then the graph crosses through the x solution, through the solution or through the x-intercept. When the multiplicity is even, an even power, then the graph is going to touch or bounce at that value. Let me show you what I mean by this. So if we go to y equals, and let's say we have x minus 3, and I'm going to do this to the second power. All right, so what's going to make that equal 0? What minus 3 is 0? 3. So this should have a 0 at 3. So we're going to take a look at it. And there it is. See how it does have a 0 at 3? But it also bounces. And the reason it bounces is because this is an even power. Watch what happens if I change that from a 2 to a 3. So we still have a 0 at 3, because 3 minus 3 is 0, but watch what happens. See how now we still have the 0 at 3, but now it goes through it? Okay, so what if I make this x minus 3 to the 6th? Do you think it's going to bounce or go through it? Is 6 even or odd? It's the power. Is 6 an even or an odd number? It's even. So when it's even, it should touch or bounce. And we'll see what happens. You can see how it's still a solution, but see how it bounces up? All right, so then what if we make it to the 7th? What's it going to do? Go through it or bounce? Through it. So I make it to the 7th. 3 is still going to be a 0. But now it goes through it at 3, okay? All right, so we're going to look at the relationship then between these solutions and the multiplicity. We're just going to do the odds together. So trying to solve this, what's the GCF? What can each of these two be divided by? R, so I'm going to take out an R. And then I'm going to be left with 36R squared minus 1 equals 0. So now I want to try to keep on factoring. I bring down the r, and then this is the difference of two squares. So this is going to go 6r minus 1 and 6r plus 1. Now, when we find solutions, I just want you to get in the habit of writing the solutions from smallest to largest. Okay, so think ahead. What's going to be the solution for this? What makes that equal 0? Just 0. Look, guys, you're going to set each one equal to 0. R equals 0, 6r minus 1 equals 0, and 6r plus 1 equals 0. So we already have one of our solutions of 0. Can you think of what that solution is going to end up being? 1 over 6 would be the final answer, and this would be what? Right, and I want you to write these in order from smallest to largest. So what's going to be the smallest solution we get? Okay, so we're going to write that first. Now write, what's the next largest? This one is 0, and this one you take this over and divide by 6, and what is it? Right. So those are going to be the zeros right there. And we don't have any multiplicity other than 1, because those are all just, single factors. All right, let's take a look at this now. What do we always have to get the equation set equal to first? Yeah. So I'm going to add y to the 4th over. All right. So this is y to the 4th. Now, I have 3 terms. So if you remember back to that paper we had, we've got that paper that tells us the flow chart. So when we have three terms, there's really only one way to solve when we have three terms. We want to factor into two binomials if we can. That's the only thing we can do with three terms. So I'm going to go ahead and I'm going to set this up. Now, what times what gives me y to the fourth is going to be y squared times y squared. And then what numbers multiply to be 36 and add to be 13? Good. And if you didn't know that, she got it, but if we didn't know that, we could look here. All of our factors of 36 are listed. And we want the ones that would add to be 13, and so that's going to be 9 and 4. Now, we want them to add to be a negative 13, so what do we need the signs to be? Negative on both. So now we're down to two terms, in two terms. So when we have two terms, we have to be looking for, is it the difference of two squares? That's when we have two terms. Or is it the difference of cubes? Or is it the sum of cubes? Well, these are both perfect squares. Okay? So if it's perfect squares, these are going to factor down into y plus 3, y minus 3, and then how's this going to go? Good. Now, try to think ahead. What's going to be the smallest solution we get? Okay, we're going to get negative 2, positive 2, and we're going to get negative 3, positive 3. So we're going to have negative 3. The next smallest one would be negative 2, positive 2, and positive 3. Those are going to be our four solutions. So before, all we were doing was just factoring. We weren't taking it all the way down to solving it. So that's the only thing we're adding on. Okay, now I want you to look at this one. We're going to find the zeros, and we also want to look at how does that relate to the graph. Now, on the homework, they're going to ask you to graph some functions. You don't even have to graph. I just want you to be able to find the zeros. So even if the directions say find the zeros and sketch the graph, you don't have to. I just want you to kind of look at the relationship, but you don't have to sketch it. All right, so if I'm finding zeros, I set it equal to 0. What is it that these can all three be divided by?
X.
Higher.
X squared.
X squared. So I'm going to factor out an x squared. So when I factor out an x squared, I'm going to be left with x squared minus x minus 12. Okay, this we can't do anything else with, but can we factor further on the trinomial? How's the trinomial going to factor? Are there numbers that multiply to be 12 and subtract to be 1? 3 and 4, good. And we would need which one to be negative? Good. So we're going to have the 4 negative, and we're going to have the 3 positive. And so our solutions then are going to be, what makes x squared equal 0? Just 0. Yeah, so 0 is going to be a solution. What's the solution on this? What plus 3 is 0? Negative 3. And this is going to be what minus 4 is 0? 4. But here's the thing. I want you to write these from smallest to largest. And this 0, because we had an x squared, that means something about the multiplicity. Since this is an x squared, I have to say 0 is a multiplicity. We'll call that MULT, multiplicity of 2 on the 0. Okay, so we have a multiplicity of 2 on the 0 because we have x is being used as a factor twice. And now, I gave you a graph, but like I said, you could just use the graphing calculator to graph it. I just want us to look at this graph and see the relationship. So let's put in the original function. And let's do a zoom 6. And let's look at these solutions. So remember how we said -3 is a 0? Can you see how that is at -3? And this is at 0, but see how it's just bouncing right there? And that happens because it's a 0 twice. And because that multiplicity of 2. And then it goes through the 4, and that's because that's just a factor one time. So just looking at that relationship, we don't have to be exact in this. I would like you to kind of copy that down though. Put the -3, the 0, and the 4. We're not being super exact. I just want you to see that it goes down like this, comes back up, hits that point, and then comes back up again. And the reason that happens right there at 0 is because of that multiplicity of 2. Okay? So look at just a regular, just x to the 4th. Just any x to the 4th graph. See how it always goes up at the ends? And this one goes up at the ends. But I can't really see how far down that is. Let me do a lower on the y, min. Let's go -50. So this is how that graph really looks. See how it goes down further? But I just wanted you to see that right there, that causes the bounce. All right, let's do one more. Let's do, this one's not going to be too different. Let's go ahead and do 6. All right, so I'm going to set this equal to 0. And what's a good thing to use when I have 4 terms? Good process to use for factoring when I have 4 terms. Grouping, okay? So I'm going to look at these 2 and these 2. What can I factor out of these 2?
X.
So I have x squared, x plus 4. What can I factor out of these?
6.
-6, and then I have x plus 4. So now I'm going to have x plus 4 that I'm going to factor out, and then I'm left with x squared minus 6. Now, I can't factor that out any further because that's not a perfect square. So all I can do is set this equal to 0. What's the solution on that? -4. And then I just have to set this equal to 0 because I can't factor it any further. So then I have to add 6, x squared equals 6. How do I get x by itself? Take the square root. And so now x is going to be equal to plus or minus the square root of 6. Now, can you approximate what the square root of 6 is about? Do you know the square root of 4? Square root of 9? So this is going to be in between 2 and 3, right? 2.4 maybe? Okay, so I'm going to go to -4 and put the 0. This is going to be about -2.4, put the 0. And then I have positive 2.4. Okay, so now listing all my x's, I had -4, negative radical 6, and positive radical 6. Those were all of our zeros. Now, the next thing, I don't really expect you to be able to do that yet, but let's just go ahead and type this into our calculator. Oops, I forgot to do a zoom 6. Let me do that. Okay, so getting rid of the other function, and see how it's going through right there at -4. That's our negative radical 6, and that's our positive radical 6. And it's got this basic shape to it. We don't care exactly what's going on. We just want a basic shape of it. Okay? And that's all there is to it for today. Again, you don't have to do the graphing even though it tells you to. Just find the zeros.